Okay, we're gonna be doing some tests, AP test prep solutions here. So we're gonna start. We're gonna work on number 3 right now. Look at the following sketch. That's a distance versus time graph. That's the first important thing to notice. And then part A is we're gonna fill out this table here. So let's go blue. So the time interval from A to B. So that's this right here. One word to describe the velocity from list 2. Well, list 2, positive, negative, or 0. The velocity, the distance is getting further away, so we're going to say positive. The speed from one word from list 1, constant, increasing, or decreasing. Here you can see the slope is decreasing over time, so that must mean that the speed is decreasing, so decreasing. The acceleration. In this case, the object is moving slower and slower, and it initially has a positive, so it has a negative acceleration. So negative. Okay, from B to C. From B to C, the velocity is, in this case, it is negative. The distance is decreasing. The speed is increasing. Notice that the slope is getting higher and higher in the negative direction, so the speed is increasing. And the acceleration is, from list 2, is negative still, right? The acceleration direction has not changed at all through this entire journey right here. So it's still negative. C to D. Let's go back to blue. The velocity, in this case, is positive again. The speed is constant. You can tell because the slope's constant. And the acceleration is 0. If the speed is constant, the acceleration is 0. From D to E. The velocity in this case is 0 because the distance is not increasing. The speed is certainly constant at 0. And if there's no speed, there's no acceleration. It's also 0. Okay. So which is faster? The average, let's change this color a little bit. Okay. What is faster, the average velocity from C to D or from C to E? So let's just do a quick erase. And let's take a look at these. Now the average velocity from C to D is easy because the slope is constant through the entire thing. So now we're just going to ask ourselves, is this slope versus this slope? Which one has a higher average slope? And of course C to D. So it has higher average slope. So higher average slope. What's the instantaneous velocity at point B? Point B is right here. That is the turnaround point, if you think about it. So the instantaneous velocity right there is 0. A couple of points that are not. What are the couple of points that are not realistic representations of how objects move? So let's pick those points out. Here, let's take a look at C. The problem with C is you have this very high negative velocity, and then it instantaneously switches to a positive velocity. Now that never happens in real life. You have to basically, no matter what your acceleration is, you have to have a turnaround point. You have to have some point where the slope is equal to 0, and you cannot have an instantaneous change right there in your velocity to go straight from negative to just instantaneously positive. It can't happen. Likewise in D, you can't have a velocity that's positive and then instantaneously have it be 0. It has to be continuous if you want to use a math term. So it has to be continuous. And so C and D are not realistic points because they are not continuous. So C and D. Sketch of velocity versus time graph. Okay. So let's do that over here. So velocity, time. All right, so A, the velocity starts off positive, B, the velocity hits 0, C, the velocity is very negative. So A, B, C should not be too difficult to do. A, B, and I'm not, by the way, this is not drawn to scale. If the acceleration is constant throughout that point, that slope's going to be straight. So here we go, A, B, C. Now the problem is C is not a realistic point. C instantaneously jumps to a positive velocity. Now that velocity is not as high as it was at A, so we can't have it up this high here. We got to have it a little bit lower. So that so again, this is not a realistic thing to have. That's why it's called discontinuous. Point C, as it goes to point D, has a velocity, a positive constant velocity. And then if you look at now I'm assuming that this line right here is straight across. So we would have a zero velocity. Well, I guess it has to be because I was right over here. So it does have a zero velocity. So from D to E, again, another discontinuous point right here. This would be D to E. I want to point out that the answer key is incorrect here. The answer key goes like this for D to E, but it cannot be because the velocity is zero. It is certainly not it is certainly not positive. So the answer key is wrong from D to E. And that is how you solve number 3.